All right, today, ladies and gentlemen, we are going to be adding and subtracting rational expressions. And as with adding and subtracting fractions, this is actually a little bit more difficult than multiplying and dividing them because you need the theme of the day, which is common denominator. All right, when you multiply and divide fractions or rational expressions, all you have to do is multiply the top and multiply the bottom. But when you add and subtract them, you cannot add and subtract unless you have a common denominator. Otherwise, it's like apples to oranges. So sometime back in elementary, you learned how to add things like 2/3 plus 7/2. So let's go back there. A lot of the things we've done this chapter, we have connected to old things because we're really just working with fractions. It's just that those fractions happen to be polynomials on the top and bottom. Sometimes your common denominator is going to be just the sum or the product of the two denominators. So in this case, my common denominator is going to be 6. So I need to multiply this fraction on the left by 2 over 2, and the one on the right by 3 over 3. You can multiply anything by 1 and not change its value as long as you make that 1 into, make it look the way you want it to look. And in this case, I want it to look like a fraction, so 2 over 2. So over on the left, I get 4/6, and on the right, I get 21/6. And once the denominators match, then I can just add the numerators and leave the denominator at 6. Making that denominator 12 is probably the most common mistake. And I don't think that you would do that at this point in your life, but you might do it when it turns into a rational function, so just be careful. So 2/3 plus 7/2 is the same as 25/6. Okay, so now let's move to the present. Same idea. You want to have common denominators so that you can add. Before we get there, however, let's factor, all right? As this entire unit, the first thing we always do is factor to get these rational expressions looking the best that they can possibly look. So on the bottom right away I notice a difference of 2 squares, which will factor to x minus y and x plus y, and that's going to simplify this process right away. But nothing will factor on the right, by the way. But I can cancel out x minus y and x minus y. Now, you can never cancel something that is added to something else unless you cancel the entire, in this case, binomial. I can do x minus y and x minus y, and that leaves me with a 1 on top. Okay, so now I'm adding 1 over x plus y and 1 over 2x plus 3y. Again, the theme of the day, common denominators. In this case, the common denominator is just the product of the two denominators. So the fraction on the right needs to be multiplied by x plus y on the bottom. That's fine. Just multiply it by x plus y on top. Over here, 2x plus 3y, top and bottom. Okay, just like we did with our fractions a minute ago. All right, so now we're going to get 2 new fractions. This one is 2x plus 3y over 2x plus 3y times x plus y. And my second one is x plus y over the same common denominator. And now I'm ready to add them. And it's not going to get a whole lot simpler. My common denominator is going to be the denominator of my answer. And on the top, I'm adding 2x plus 3y to x plus y, which gives me 3x plus 4y. And you have to look when you're done to see if anything would cancel, but nothing's going to cancel. You know, some things that people would try to do is like cancel that x and that x, or that 3 and that 3, which are just things that you're not allowed to do. Don't cancel something that's added to something else unless you're going to cancel out entire factors. All right, so let's do one more. We start by factoring. Always start by factoring. Nothing will factor from 3x plus 13. The bottom of this one looks like it'll factor to let's see, that minus 10, I need two factors of negative 10, which look like negative 5 and positive 2. And I'm going to subtract 16 over, let's see, that one is like x minus 5, x minus 1. All right, so this one's slightly different because the least common denominator is not just the left denominator times the right denominator. This is kind of like adding 1/8 plus 1/6. My least common denominator is not 8 times 6, which is 48. It's the smallest number that both 8 and 6 go into. If you consider 8 to be 2 times 2 times 2 and 6 to be 3 times 2, that might help maybe. Let's see, the 8 and 6 both go into 24. So I'd multiply to get 24 on the bottom. I don't have to just always multiply the two together. It doesn't necessarily mean it was wrong. It would just need more simplifying later. So my point is, the fraction on the left, in order to get the common denominator, needs an x minus 1. Basically, you just give it the parts that it's lacking. The one on the right needs an x plus 2. Right? I didn't need to multiply each one by x minus 5 top and bottom because I already had the common denominator. And you can see by adding an x minus 1 on the left and an x plus 2 on the right, I have the exact same denominator. Okay, so now we multiply out on top. Sometimes you have to FOIL on top, sadly, sorry. But I need to FOIL these two binomials. I get 3x squared plus 13x minus 3x minus 13, or 3x squared plus 10x minus 13 over the common denominator. Minus 16x plus 32 over the common denominator. And now I'm ready to subtract. Now here's another common mistake. When I'm subtracting this fraction on the left, I'm subtracting all of this, which means that negative needs to go here, and it needs to go here. All right, so I have 3x squared. I have 10x, and I'm going to subtract 16x from that, get negative 6x. I have negative 13, and I need to subtract 32 from that, which gives me negative 45 over my common denominator. And what you'll notice sometimes is when you do this process, you create new expressions that can be factored and possibly cancel further. What I notice right away about my numerator is that 3 goes into it. Try to write in that denominator again. Oh, never mind. I'll just write it again. Being lazy. And now if you can factor, this won't always happen, but if you can factor and cancel more, you always need to write it in its most simplified form. So x squared minus 2x minus 15 looks like x minus 5x plus 3. We'll go into that over my common denominator. So what happens is the x minus 5's cancel. I'm left with 3 times x plus 3 on the top, and x minus 1, x plus 2 on the bottom. And that could be multiplied out. It could be 3x plus 9 on top. Might as well just leave it in factored form and call it a day. All right, so we're adding, subtracting fractions, just like back in elementary school. Get your common denominator, which you can find through factoring, cancel what you can, add the rest, cancel again if you need to. All right, this is it. Adding and subtracting rationals. Young out.